Okay, so let's just stop what you're doing so we don't need our computers open. We're just going to have a pause and we'll just talk about everything we just saw together. Most people are either finished or pretty well finished. So first one, we did f of x plus d, and what we saw is as we move d, it just moves the function up and down. Then we had f of x take c, and we saw that it moves it to the left and to the right. Okay, so maybe just to make a clarification for you, all right, if you have f of x plus c moves it c units left, okay, ironically, plus c moves it to the left, and f of x takes c moves it c units right, okay, so that's the distinction there. C units left, C units right. So if we've got in the negative values, we can see we're moving it to the left. With the positive values, we're moving it to the right. Okay, then we moved on to dilations. Okay, so we're going to be using that word dilations. Dilation, a bit like how you understand the pupil of your eye dilates to receive different amounts of light, right? And so what's happening is that means it's growing and shrinking, okay? And if we have this number out the front, this a value out the front, all right, and I've asked two questions about it. I said, first, make it big for values larger than 1, okay? So when a is 1, if I can just set a as 1 there, you can type it, that helps. If a is not -1, positive 1, if a is positive 1, it's the same function. And why is that? Because if I have the number out the front, if I have 1 f of x, all it means is 1 times f of x. But then let's look what happens if I set it as 2. All right, if I set a as 2, we've got 2 times f of x. What is f of x? F of x is the y value. And so look here on the function the y value is 1, okay? And if we have 2 times the y value, what's it doing? It's doubling it. All right, now the y value is 2. If we set it as 3, it's pushing it further and further away from the x-axis by a factor of a. Whatever that a number is, it's stretching it that far away from the x-axis. So stretching it further away from the x-axis, and then I said, now choose a number between 0 and 1. Okay, so it might be half or something like that. What's it doing? It's halving. Of course it's true. It's a number out the front. If you have a f of x, that's all. If you have a f of x, whatever that number is, it's going to multiply the function by it. So 0.5 times f of x, it halves everything. Okay, so that's the dilation factor. That's what we call a vertical dilation factor because it scales it vertically. Okay, vertical dilation factor. And then we put in a b in the middle here, didn't we? We put a b in, we add a slider b, and this is a horizontal dilation factor because as b gets large, it squishes it closer and closer together. It's squashing it, it's compressing the wave, and then as b gets between, we won't look at negative values, but as b gets between 0 and 1, as it gets closer to 0, it's stretching it further and further and further apart. Okay, so as b gets large, squashes it. As b approaches 0, gets closer and closer to 0, it's stretching it further and further apart. I said don't consider negative values. And then the last one was, we graphed a different function. It was x squared plus 2x. 2x. And then we graphed y equals, firstly, minus f of x. Okay? And what we're seeing it do is it just reflects it in the x-axis, it flips it. And again, of course this is true because now we've got -1 times f of x. It makes every positive y value negative and every negative y value positive. Look, all of these y values are positive. We've put a negative in front of it, it makes them all negative. It's putting them down here. All of these y values are negative. If we put a negative in front of a negative, it makes it positive. So we have the reflection there in the x-axis. That's what the negative out the front does. And then we have the reflection in the y-axis. That's what that negative does. It's a mirror image of it in that direction. Very good. So what we're doing today then is question 1 and 2 from the textbook of exercise 3F1, 2 and 3. And rather than drawing it out, I've printed these off for you. So I've given you 2 handouts, right? The first one, that was for your notes book. Okay, we were taking notes, that was for your notes book. The second one is just the textbook, all right? So you don't have to keep this one as such. You don't even have to use it, but it is going to be helpful because we're given a graph alongside here. Here's the function, okay? What's our job? On a separate axis, draw the graph of y equals f of x plus 5. So that means on here we can sketch the function y equals f of x plus 5. What's that plus 5 do? It moves everything up 5 units. So if I'm going to draw that, let's see if I can get my laptop to work. Beautiful. So this point here is moving up 5 units. So there's 0, 5 is going to be there. All right. So that point moves to there. This point's at -3. It moves up 5 units. So it's going to be there. Okay. Same with this point, moves up 5 units, up 5 units. And so I'm going to sketch it again. I'm going to move all those points up 5 units. And then that one goes to there. It's a little bit clunky, but that's the function that results when you move this up 5 units. This is the graph of f of x plus 5. So what you're doing today then is making those transformations. All right? F of x take 3. What's it do? Moves it c units to the right. All right, so let's see how we go with that exercise. That's it for today. Any questions?
Can we just do it on the sheet or do we have to do it?
You do it on the sheet. Yeah, that's what I printed it for. Yeah, I printed it.